Hi guys, we are Slope BFFs and today we will be teaching you how to get the slope of the tangent line using the limit process. But before that, don't forget to like and subscribe below. Ooh.
In this video, we're going to show you how to get a slope of a tangent line using the limit process. Because when you get the slope of a tangent line, there are two ways. Firstly, using the derivative rules. They're basically the shortcuts already. But in this video, we're going to show you the limit process, which is the more complete version of getting a slope of a tangent line. Before you get the slope of the tangent line, you need to first get the derivative of the function. Then afterwards, you evaluate the derivative of the function using the given x.
Okay, so our first example, the easy example, we're going to start with finding the slope of a tangent line using polynomials. Plus delta x into the function of x squared minus 3x plus 4. Now, when we do that, we get x squared plus 2x delta x plus delta x squared minus 3x minus 3 delta x plus 4 minus x squared plus 3x minus 4 all over delta x. Now from here, we can cancel out what can be cancelled out. We can cancel this out, and we can cancel this out, and we can cancel this out. It will then leave us with 2x delta x plus delta x squared minus 3 delta x all over delta x. Now, from here, what we need to do is to cancel out the denominator delta x. So, how we do that is we just have to factor out delta x from the numerator. So then it becomes delta x, quantity 2x plus delta x minus 3. Then we can cancel out the denominator of delta x. We are then left with 2x plus delta x minus 3. Since we have this, we can already substitute delta x with 0 since it is what delta x is approaching to. Then we end up with 2x minus 3 as our derivative. So to get the slope of a tangent line, we mainly only have to substitute the x, which is 2, into the function. Now, inputting 2 into the function would give us a 2 times 2 minus 3, which then becomes 4 minus 3, which would give us a final answer of 1. So this is our final answer for the slope of a tangent line.
Okay, for the second example, we are still going to use the polynomial function. Function is 2x cubed plus 5x. So we are going to substitute the x's in the function with f quantity x plus delta x minus f of x all over delta x. So you get 2 quantity x plus delta x cubed plus 5 quantity x plus delta x minus 2x cubed plus 5x all over delta x. From there, we can use the binomial theorem, and once you do the binomial theorem, you're able to get 2 quantity x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed plus 5x plus 5 delta x minus 2x cubed plus minus 5x all over delta x. And then from here, you can distribute the 2 to the parentheses. So it becomes 2x cubed plus 6x squared delta x plus 6x delta x squared plus 2 delta x cubed plus 5x plus 5 delta x minus 2x cubed minus 5x all over delta x. And as you can see, there are like terms, so you can cancel that out. So it becomes, so you can cancel 2x cubed and negative 2x cubed and 5x and negative 5x. So it becomes 6x squared delta x plus 6x delta x squared plus 2 delta x cubed plus 5 delta x all over delta x. So from here, our goal is to cancel the delta x on the denominator. So we factor out the delta x in the numerator. So it becomes delta x quantity 6x squared plus 6x delta x plus 2 delta x squared plus 5. So from here you can cancel the delta x's. So it becomes 6x squared plus 6x delta x plus 2 delta x squared plus 5. Now from here, since delta x is approaching 0, we can substitute the 0 to the delta x. So it becomes 6x squared plus 6x times 0 plus 2 times 0 squared plus 5. And we get 6x squared plus 5, which is the derivative of 2x cubed plus 5x. Slope of a tangent line, we just substitute our x, which is 5, to the function. So when we do that, we get 6 times 5 squared plus 5. And that gives you 6 times 25 plus 5. And 6 times 25 gives you 150 plus 5. And 150 plus 5 is equal to 155. So 155 is the slope of the tangent line.
So our function is 2x to the power of negative 2 minus 4x, where x is equal to 3. So what we first have to do is to substitute f of quantity x plus delta x minus f of x into the function. This makes it the limit as delta x approaches 0 is 2 quantity x plus delta x to the power of negative 2 minus 4 times the quantity of x plus delta x minus quantity 2x to the power of negative 2 minus 4x all over delta x. So what we want to do here is to rewrite the negative exponent, so we make it like the denominator of a fraction. So it becomes 2 times quantity of 1 over quantity x plus delta x squared minus 4x minus 4 delta x minus 2 over x squared plus 4x. Now we can cancel out the negative 4x and plus 4x, so it will become 0. So when we multiply the 2 into the fraction, it becomes 2 over x plus delta x squared minus 4 delta x minus 2 over x squared all over delta x. So our objective now is to make the numerator into a simple fraction so that we can cancel out the delta x. So the LCD of the numerator is x squared times x plus delta x squared. So it becomes 2 times x squared minus 4 delta x times x squared times x plus delta x squared minus 2 quantity times quantity x plus delta x squared all over x squared times quantity x plus delta x squared all over delta x. Okay. Afterwards, we expand the fraction and it's going to become 2x squared minus 4x to the power of 4 delta x minus 8x cubed delta x squared minus 4x squared delta x cubed minus 2x squared minus 4x delta x minus 2 delta x squared over x to the power of 4 plus 2x cubed delta x plus x squared delta x squared all over delta x. So since it's a simple fraction, we can now cancel out what are similar, so we can cancel out the 2x squared and negative 2x squared. Afterwards, we rewrite the over delta x as times 1 over delta x so that we can make it into a big simple fraction. So it becomes negative 4x to the power of 4 delta x minus 8x cubed delta x squared minus 4x squared delta x cubed minus 4x delta x minus 2 delta x squared over x to the power of 4 plus 2x cubed delta x plus x squared delta x squared times 1 over delta x. So now we can combine the denominator, so delta x times the denominator. And in order to cancel out the delta x at the denominator, we need to factor out the delta x from the numerator. So we get the factor out, so delta x, the numerator becomes delta x times negative 4x to the power of 4, negative 8x cubed times delta x minus 4x squared delta x squared minus 4x minus 2 delta x. So as you can see, there are 2 delta x's in the numerator and denominator, so you can cancel it out. And then the fraction becomes negative 4x to the power of 4 minus 8x cubed delta x minus 4x squared delta x squared minus 4x minus 2 delta x all over x to the power of 4 plus 2x cubed delta x plus x squared delta x squared. Now we can substitute the delta x as with 0 because delta x approaches 0. So just put 0 in the delta x's. So it becomes negative 4x to the power of 4 minus 8x cubed times 0 minus 4x squared times 0 squared minus 4x minus 2 times 0 over x to the power of 4 plus 2x cubed times 0 plus x squared times 0 squared. So when it's simplified, the answer is negative 4x to the power of 4 minus 4x all over x to the power of 4, which can still further be simplified into negative 4 minus 4 over x cubed. And that is the derivative of the function. In order to find the slope of the function, the slope of the tangent line of the function, we substitute x equals 3 into the derivative. So since the derivative is negative 4 minus 4 over x cubed, you just have to put 3 in the x, and it becomes negative 4 minus 4 over 27, which is further simplified into negative 4 and 4 over 27, and this is the final slope of a tangent line.
For the hard example, we're going to find the slope of a tangent line using the limit process, but for our example, the function is exponential. So our example for today is f of x is equal to e to the negative 3x. So using the limit process, we substitute the x in the function with x plus delta x, which results in e to the negative 3 to e to the power of negative 3 times quantity x plus delta x. Then for the minus f of x portion, we substitute the entire function, you input it here, so it becomes minus e to the power of negative 3x all over delta x. So you would just expand, you distribute the negative 3 of the first term into the rest of the equation, so it becomes e to the power of negative 3x minus 3 delta x minus e to the negative 3x. And as you can see here, there's a common factor, which is e to the negative 3x. So you can take it out of the numerator, so to the next portion of the solution. So you factor out e to the negative 3x times the quantity of e minus 3 delta x minus 1 all over delta x. And so you can take this out of the entire limit equation itself. So you can put it here, e to the negative 3 e to the power of negative 3x times the limit of e to the negative 3 delta x minus 1 all over delta x as delta x approaches to 0. And so we multiply the entire equation with negative 3 all over negative 3, and that does not change the value of the equation. It's basically multiplying it with 1. We need to change the form so that we are able to cancel out things, as you will see later on. So you can take out negative 3 as well because it's just going to end up in the numerator. And then here, you just distribute negative 3 to the delta x in the denominator. So you're already left with this. Like,
when you're left with this form, we can make use of the limit law, which is the limit of e to the power of x minus 1 all over x is equal, as x approaches to 0, is equal to 1. And so that was the purpose of multiplying the negative 3 over 3 in the previous part of the solution. So you can, because the negative 3 delta x and the negative 3 delta x, these two things are the same, so you can just take the entire equation as a 1. So it's negative 3 times e to the power of negative 3x times 1, and your final answer for the derivative of the equation, your f prime of x is equal to negative 3 e to the power of negative 3x. And so we're going to get the slope of the tangent line, so we have to substitute the x equal to 2 into the derivative we just got a while ago. So f prime of 2 is equal to negative 3 e to the power of negative 3 times 2, because we substituted the x as 2 in the equation, which will lead you to get negative 3 e to the power of negative 6, and you can separate the negative 3 and the e to be able to make the exponent positive, so you make it 1 over e to the 6, and so your final slope of the derivative is equal to negative 3 all over e to the 6. There you go.
Thank you so much for watching. I hope you learned a lot about getting the slope of a tangent line from this tutorial.
Don't forget to hit the like button.
And subscribe to Slope BFF.